So how many seconds are there in a minute? Hey, just like time. That works out. At least we don't have to worry about something else, right? We have this conversion here, but now we have that 1 minute is 60 seconds, right? There are 60 seconds in 1 minute. Or if you want, you could say that 1 second is 1/60th of a minute. Two different ways to look at this. Now, in the real world, there are two different ways in the real world that people use angles when we're talking about degrees. They either give you the measurement as a decimal or they give it to you in degrees, minutes, and seconds. And so what we need to be sure we can do here is work with both. So I'm going to just give you an example, all right? Let me try and explain this another way. If I told you right now that something was 1.5 feet long, right? 1.5 feet long. You could say that that's really 1 foot, right? 1.5 feet is really 1 foot and how many inches? 6, right? Because there's 12 inches in a foot. So 1.5 feet is equivalent to 1 foot 6 inches. This is the decimal version of the measurement. This is using feet and inches. What we want to be able to do is I give you an angle in decimal, and then you go to degrees, minutes, seconds. Or I give it to you in degrees, minutes, seconds, and you go to decimal. You need to be able to do both. So just like this, I give you this, you should be able to go to here. If I give you this, you should go to here. Maybe we should talk about how you do this for this simple one, right? Because I think if you see this one, it makes the other one easier. So how do we go from here to here? Well, here's what we could do. We say this is 1 foot, right, plus 0.5 feet, right? That's one way I could look at that. But now, foot, right? This is 1 foot plus 0.5 feet. How many inches are in a foot? So I'm going to put that up here. There are 12 inches in 1 foot, yes? So if I would like to get this to inches, what I have to do is get rid of feet and turn it into inches, right? So what I'll do is I'll multiply. This is something called dimensional analysis. If you go back to college algebra or even before, I'm going to multiply this by something with feet on the bottom and inches on the top. And I'm going to use this relationship here. So I know there's 12 inches in 1 foot. So I am putting this in here so that I can get my feet to cancel and my inches to show up. So what's 0.5 times 12? So half of 12 is 6. So if we put that together, we get 1 foot plus 6 inches, right? Which is this, 1 foot 6 inches. Make sense? Here, what if we wanted to go here to here? What would we do to go from here to here? I'd say, well, this is 1 foot, right? Plus 6 inches. But I want to get rid of inches and turn everything into feet, right? Everything into feet. So how can I get rid of inches and turn it into feet? I multiply by what? What do I multiply to get rid of the inches? If I want, look over here, I wanted feet to cancel, so I put feet on the bottom and inches on top. Here, I want inches to cancel, so I'm going to put inches on the bottom and I'm going to put feet on top, right? And now there are 12 inches in 1 foot. The inches cancel, and what's 6 divided by 12? 0.5, right? 6 divided by 12 is 0.5. So you get 1 foot plus 0.5 feet, which is where you get the 1.5 feet from. I hope that makes sense. So we're about to find out. Let's convert this. I want to convert Let's go with 50 degrees, 6 minutes, 21 seconds. That is an angle that I've measured, okay? I would like to convert that to a decimal, to decimal degree. And I'm going to put this over here in the corner so that we have it. We know that 1 degree is 60 minutes, and we know that 1 minute is 60 seconds. Those are our big conversion factors that we're going to use. Am I boring y'all? Are y'all okay? You all right? Okay, I know this is kind of a drag. I mean, this is like we're just trying to grind through this, but we have to have this foundation in place or else later on we're just going to stumble, all right? Okay, so I'm going to write it this way. I'm going to say this is 50 degrees. I want all my answer in degrees, but I want it as a decimal. Plus 6 minutes plus 21 seconds. Let's start with the 6 minutes. 6 minutes. If I want the minutes to go away, I have to cancel it, right? That means I need to multiply this by something that has minutes on the bottom and what on the top? Degrees, because I want my final answer to be in degrees, right? So now you come over here, which of these two connect degrees and minutes? The top one, right? So I'm going to put 1 degree over 60 minutes. 1 degree over 60 minutes. Do you see how the minute unit will cancel? Yes? Plus, okay, now I need 21 seconds to turn into degrees as well, right? But see, I don't have a connection between degrees and seconds, do I? I have to go degrees to minutes, and then I can go from minutes to seconds. So I have to do a double conversion here. I'm going to multiply this by something that gets rid of the seconds, creates minutes. That's this one. And then multiply again by the thing that takes the minutes to degrees. So what goes on top and bottom here? How many minutes? 1 over 60, and then here? 60 minutes here and 1 degree there, right? So I'm just going to kind of, again, stress the fact that, see, the degrees go away here. So my answer here is going to be in degrees. Then here, these seconds cancel. Now I've got minutes, but then the minutes cancel, and now I've got degrees. So I just have to do this arithmetic on my calculator. 50 degrees plus, here, that 6 is really on top, isn't it? So 6 over 60 is 0.1 degrees. It's 1/10, but I'm going to do this as a decimal, right? So I'm going to just go 0.1, that's 6 divided by 60, degrees. Plus here, I'm going to do 21 times 1 times 1, so 21 over 60 times 60. Someone do that for me? 21 divided by 3,600?
0,0583, and then the 3 repeats forever.
The 3 repeats? Okay, so we'll just leave it like that then. Most of the time they'll tell you in the problem, I'll say to round a certain number of decimals. Here, 4 decimal places, what it says. So we'll just stop there. Part 5 what?
583.
583, I'm sorry, I didn't hear you say 8. Thank you. 83 degrees, all right? And now we just add all those together. Just add them all up. So we should get 50.1053 degrees. So 50 degrees, 6 minutes, 21 seconds is equivalent to 50.10583 degrees. If you wanted it all in degrees, that's the answer. If you want the minutes and seconds, this is the answer. We got questions or not? Let's go backwards. Go ahead.
How do you get the last 0.00583?
This right here is really 21 over 60 times 60, which is 21 over 3,600. You just, because this is multiplication of fractions, right? So you multiply straight across, you treat the 21 like 21 over 1. So you go straight across top, straight across the bottom. That make sense? All right. Let's take that answer and go back to this. Okay? Because going backwards is a little bit weird. So we know this is going to be our final answer. But let's start with this. Let's start with 51 or 50.10583 degrees, and let's convert this to degrees, minutes, seconds. You get the idea, right? I want that to degrees, minutes, seconds. This is a little weird, all right, what we do now. I'm going to write this is equal to 50 degrees plus 0.10583 degrees. Anybody disagree with that? 50.1058 degrees is equal to 50 degrees plus 0.1053 degrees. Yes? Okay, let's try and turn this into minutes. So I'm going to have to multiply this, right, by something to make the degrees go away. So I want degrees on the bottom, and I want what on top? Minutes. What's the conversion factor with this? 60 over 1, right? 60 over 1. So 60 over 1. And then, again, this is what we're doing here is all we're doing is treating this like two fractions. And we're multiplying straight across. And the degrees are going to cancel. So let me write down my next line. I have this. 50 degrees plus, now on our calculator, we're going to do 0.10583 times 60. Oops, I messed that up. What do y'all get? 6.34, something like that? Yes? So this is going to be 6.34. Are y'all getting 9.8? Yeah. 9.8 what? Minutes, right? Minutes. So 50 degrees plus this many degrees is the same as 50 degrees plus 6.3498 minutes, right? So next line will be this. 50 degrees plus, this is 6 minutes plus 0.3498 minutes. So again, I'm splitting this up into two pieces so that now I can use the conversion factor on this piece and get that to seconds. So what do I have to multiply this thing by to get rid of the degree, or to get rid of the minutes here and create seconds?
60 seconds over 1 minute.
60 seconds over 1 minute, exactly. See, I'm not working with this because I already know how many minutes I have as a whole number, right? There are 6 minutes, but there's a decimal part that needs to be converted over to the seconds. So I'm taking only the decimal part and doing the conversion factor on just the decimal part. So you need to do that. So what happens when you multiply that? What do you get? 20 what? 0.98? Okay, so 6 plus 20.98, you said? 98 seconds, right? Now the reason why this is not what was it supposed to be? 21. The reason it's not is because remember when we did it the other way and got this answer? What was your name, sir?
Brandon.
Brandon, you said the 3's went forever, right? And we rounded it. So it's when we went backwards, it's not exact. But good enough, right? I don't even know if there probably is something further down than a second that you can do. Like if you cut a second into 60 pieces, there's probably a name for it. I don't know what it is. But we're stopping here, all right? Any questions on the conversion? Degree decimal converted to degree minute second, or the other way around. Degree minute second converted to decimal. You go both directions. All right. Yes?
So for the seconds, would you just round it to 21?
I would round it to 21, yeah. But technically, I mean, you can have a decimal for a number of seconds. I mean, it's not wrong, but for all purposes here, we just round it to 21. All right, so this is where things start to get a little weird, I think. Is there a question? You sure? Oh, okay. Looked like you went like that. Yeah. Oh, your hair or something? Okay, all right. So I just want you to just take a step back before we get into this next topic, because I think students do struggle with this idea of radians. Radians. So let's remind ourselves, when it comes to degrees, the idea of a degree came from looking at a full revolution, right? You take your full revolution and you cut it into 360 equal pieces. Who said 360? I don't know. Not me, but that's what they chose, right? Could have been any number. That's what they chose. And we've worked with that for all of our lives. That's not the only way to measure an angle. There's another way to measure it, and it's called radians. And it's not at all like the way degrees was, I guess, founded. They didn't look at a full revolution and say, oh, let's cut it into a certain number of pieces. Here's what they did. It's actually pretty amazing if you can wrap your head around what it is. So imagine I start here by drawing a standard, like in standard position. I'm going to start to draw an angle, but instead of thinking about an angle, I want you to think about a circle. I want you to go out a certain distance. Let's just say that distance right there, let's just call that r, lowercase r, all right? And from that r, I want you to imagine drawing a circle, which we studied circles last class, right? You draw a circle around here, right, all the way around like this. You got your circle. Yeah? Yeah? I need something, let me see. I can probably use this. Come on. That's R, right? That's R. Wrap it around. Let me do it this way. Wrap it around. That's how you come up with this circle. What I want to do is I want to take this R right there, and I want to wrap it around the curve of the circle. You see that? So that if you were to walk along this, that distance that you walk around that circle is also R. You with me? So I'm calling this distance from here walking around, you know what, I want to be pretty accurate with this. So if from here to here is R, when I wrap around, it's about right there. Okay, see that? That distance from here to here is also R. Do you agree with me? And that naturally forms an angle, doesn't it? That naturally forms an angle if I connect here. This is some angle right here, right? Okay, cool. Who gives a shit, right? Well, let me do the same thing with a different circle. Okay, so now I'm going to take another circle. I'm kind of out of colors here. So let me take a larger circle. Let me let my radius go out to here instead, okay? So I'm going to stop there instead, all right? And I'm going to draw myself a circle here. Who wants to be on camera? Who wants to volunteer real quick? I need a hand. Please, not all at the same time. Oh, come on up. You're going to be on camera, is that all right?
That's fine.
Okay.
Do I need to sign a release form?
Probably. Here, just take that to the origin. This is just to help us get more accurate here. Got it? Take it over. There you go. Okay, I'm going to try and do this. Oh, shit. Okay, right about there. Okay, thank you. That's all I needed.
Okay.
All right, so that circle just kept going, right? Yes? Now, if I measure this radius from here to here, I'm going to call that distance from here to here, let's call it let's call it R1. I should call that R0, but I'll call this R1. That's a different radius, right? If I wrap that around this circle, okay, if I start wrapping that around this circle and walk that same distance, okay, walk that same distance right here, where this right here is R1, guess what? This angle is the same angle. And it doesn't matter what radius you ever use. If I take a smaller radius, let's say I only go from here to here, and I draw a little circle around here, right? And then I measure that, and then I go around that distance, it's here, that's the same angle. It's kind of weird, right? I mean, it's always the same angle. If you go out and then walk along that circle the same distance you went out, you will always have the same angle. There's something really unique about that angle, right? Isn't there something kind of unique about that? We should call it something. Maybe we should name it. Because this works for any distance you ever go, right? No matter what. Go out, 1 foot, 2 feet, 10 feet, a mile. Draw a circle, go that same distance around the circle. We're all talking about the same angle. Maybe we should call it a radian. Let's call it a radian, right? This angle right here is called 1 radian. It's called 1 radian. And the notation for it, you know how 1 degree, we write 1 with the degree symbol? The notation, so 1 degree is not 1 radian. The notation for 1 radian is 1 rad, okay? But I need to warn you, all right, that if you're ever doing a problem and they give you, hey, the angle is 4, and they don't say degrees, it is assumed to be radians. All angles are assumed to be in radians unless it's specified that it's degrees. You catch me on that? Your calculators have 2 modes on them. We'll see this as we move on. When we're doing problems in this class and we start doing sine functions, cosine functions, tangent, I'm going to say, make sure you're in the correct mode. You're either in degree mode or radian mode. Your calculator needs to know, how are you measuring angles? This way or this way? All right, so you tell me, what quadrant is 1 radian in? First quadrant. 1 radian is always in first quadrant, right? How many degrees were there in a full revolution? Right? When you go all the way around, in degrees, there were 360 of those degrees in there, right? So if you look at 1 degree, it's really small, right? That's 1 degree right here. And there's 360 of those in a full revolution. How many radians do you think there are in a full revolution? What does it look like to you? I heard 8. It kind of looks a little bit, right? Like maybe it's like 1, 2, 3, 4, 5, 6, 7, 8. Maybe it looks like 8 to you? Sorry, it's not that nice. It's actually, I mean, that's a good guess. My drawing is limited. This angle is what is it? It's 1 radian, right? So how many of them are in a full revolution? No, not 16. Did you say 16?
Yeah.
No. It's a weird-ass number, okay? It's not what you want it to be. You want it to be a nice number, don't you? You want it to be 8, 16, 4, right? You want it to be a nice, even amount. But see, here's the thing. This is a natural occurring thing. We didn't get to choose this, right? This is just the way it works. You go out, walk around the same distance, that forms an angle, no matter how you do it. That angle, there's nothing that says it has to fit into a full revolution, right? So no one knows how many radians there are? One revolution? One revolution is equal to, the question is how many, right? Question mark, how many radians are in one full revolution? One revolution is equal to 360 degrees. We already know that, right? But in radians, what is it? 2 pi. 2 pi. So everyone gets all pissed off because like 2 pi, what the hell 2 pi? What is pi approximately? Pi is about 3.415. So 2 pi as a decimal is about approximately 6.28. It's not a nice number, sorry. Okay, I didn't make it up. This is just the natural way that the world works, the universe works, okay? This is how many of these you would need to go around once. You would have one of them, 2 of them, 3 of them, 4 of them, 5 of them, 6 and not quite 7. It would be 6 and some change. All right, that's the way it is. Now, I'm not here to prove that to you. All right, I'm not here to prove it to you. You have to take that on faith. Take me for Cal 2. We will prove that that's true. All right, we can't do it here. We don't have the tools. All right, questions? 1 radian. So from that, we're gonna march right on to a very nice result of this. You know what? Before I do that, let's do this. We may as well. So far, there are some common angles that we've already looked at in degrees. So this right here is 0 degrees, right? If you just point straight out to the right, that's 0 degrees. That's also 0 radians. Now notice I'm not putting anything here. I'm not putting rad. You need to understand I mean radians here. 0 degrees is equal to 0 radians. Now, how about this straight up one? How many degrees? Straight up? 90 degrees. How about over this way? 180. And straight down was 270. Okay, those are the first ones we talked about, right? Let's talk about those in terms of radians. So look, all the way around is how many radians? 2 pi. So what would halfway around be? Just pi radians. So this is the same as pi radians. All the way around's 2, so halfway would be pi. How about 90? It would be half of this, wouldn't it? It'd be half of this. So I could put pi over 2. Notice I'm not getting on my calculator and like calculating pi divided by 2. I'm leaving it as pi over 2. Let's see. See if you can keep up with this. If I go from here to here, that's pi over 2, right? So I've rotated by pi over 2, 90 degrees or pi over 2. Rotated by pi over 2. And then if I go by pi over 2 again, I'd be here, right? So you're saying this is 1 pi over 2, and here's 2 of them, right? 1 pi over 2 and 2 pi over 2. 1 pi over 2, so this is 1 pi over 2. This is 2 pi over 2s, 2 pi over 2s. And do you see the 2's cancel and you just get pi? And then if I rotate again by pi over 2, that's how many of them now? 3 pi over 2s, right? That's 1 pi over 2, 2, and 3 pi over 2. So this is 3 pi over 2s. Do you all understand that? And these don't cancel. So we just leave this as 3 pi over 2. Actually, we write it 3 pi over 2. Let's go again. Here to here. How many pi over 2s is that? It's 4 of them, right? Let me go. 1 of them, 2 of them, 3 of them, 4 of them. Right? What's 4 pi over 2? 4 times pi over 2s. What happens to the cancel out and you get 2 pi. Do you all see how I just counted my way around the circle? I advise that you learn it that way. It's so much easier than just trying to learn the angles. Count your way around the circle. Pi over 2. 2 pi over 2, which reduces to be pi. 3 pi over 2 doesn't reduce. 3 pi over 2. 4 pi over 2. Got it? Let's try the same thing with the 45 degrees. This is 45 degrees, yes? What is that in terms of pi? Pi over 4, right? Because if this is pi over 2, that's halfway, right? So this would be half of that. So this is pi over 4. Right? This is so exciting. For me. For me it is. I want you to count your way around. 0, right? How many pi over 4s here? 1. Where would 2 pi over 4s be? Straight up, right? Think about what that looks like. 2 pi over 4s, right? Doesn't that reduce to pi over 2, which matches what we said a second ago, yes? Keep going. How many pi, where are we? Pi over 4, 2 pi over 4, 3 pi over 4. Can that reduce? No. Where are we next? 4 pi over 4s. Does that reduce? Yes. 4 pi over 4. The 4s cancel, you get pi, which matches what we knew it was, right? What about this one? We're at the 5th one, right? 5 pi over 4. Does that reduce? No. Okay, next one. What are we at? 6 pi over 4. Does that reduce? Yes, it reduces to 3 pi over 2. You see how everything is like working out perfectly here? What's the next one? 7 pi over 4. Does that reduce? No. Last one. 8 pi over 4. Does that reduce? Yes, to 2 pi. See that? We should all be comfortable with the degrees. 45, 90, add 45, 35, 135, add 45 again, 180, right? Counting, by degrees is easy. Counting by radians is a little harder. So I always recommend that you learn it this way. Just count them out. Pi over 4, 2 pi over 4.